first part of the circle stuff, we know most of these definitions already. And I just want to kind of remind ourselves of what they are. Your best bet is to just kind of draw a quick circle, and we're going to label a few things here, just so that way we understand where the parts go. I mean, for example, we know what a radius is, we know what a diameter is, we know what a chord is. We've talked about those. So those are going to be some that aren't going to be so bad. Okay? For example, radius is just from the center to the side. Okay. The diameter then is side to side through the center. Excuse me, side to side through the center, which again we do. It has endpoints on. Whole thing's the diameter. The new ones that you may not remember is a chord. A chord is a segment in a circle with endpoints on the circle. Basically, a diameter would technically be a chord. And those come back in with segment stuff here in a couple of days when we get back into what are called chords and arcs and how those interact with one another. React with one another. I don't want to say react, but how they fix this. So, like this. Segment in a circle with endpoints on a circle. It's a chord. And then the other two that will be new are a thing called a secant and a tangent. The tangent thing here is not trig. It's not trig related. It's not opposite adjacent. It's something different. And the secant is actually a trig thing as well, but it's not in this case. A secant is going to be a line that goes through a circle. That's something. It's like on fingers like, oh no, it's dead. A secant is a line through a circle. So a secant goes through it. Okay. That would be a secant. It touches the circle in two spots. Excuse me. What's that? Oh. And the last one is this thing called a tangent. Tangent segments are lines. They're going to be segments or lines. Let me move this up just a bit here. That touch the circle. At one spot. They are perpendicular to a radius. A tangent segment's always be perpendicular to a radius. Draw that out here. So we had our radius that I badly drew earlier. Draw it better. That was my radius. Here's a tangent. It touches the circle at one spot that's perpendicular to the radius. We look at these things a lot because they, again, when we see right angles, that means you'll have Pythagorean theorem, you have right triangles. Not so much SOHCAHTOA stuff, but it can happen again, special right triangles, things like that. What's crazy about the way that circles go is that I kind of understand why they put it at the very end of the unit of the book now, because in circles you can put everything you've learned. Bonjour. Bonjour. So I should have said oui, oui, senor. That's from a movie. You guys ever seen Clue? There's a movie called Clue. It's done in the probably like mid-late 80s. It's fantastic. It follows the board game idea. It's so they do the shadow cast of it over at. You've done it. What are they doing that one again soon? Okay, we went and saw that a couple years ago. It was hysterical, so funny. The shadow cast they go over to the Egyptian theater where they'll play the movie in the background. They'll act it out in front. If you get a chance to see Clue, Clue is a really funny movie. It's really good, but there's a part there that says. We have it down. No, I just have to go part of my nose. So anyway, a tangent thing, but we never go off on those. She hates me. So profound. Yes, I know exactly what you mean. That sounds going. Anyway, I know it's a play on words. I believe that the tangent part it has where you do touch something at one spot, you consider it. The other part with the trig is a whole different. But we've done with this stuff here. A lot of the stuff that we're going to look at over the course of the next couple of weeks, these vocab words keep coming back up. Secant, tangent, chord, things like that. Arcs, intercepted arcs, central angles, all the stuff that we've talked about before come back again in here. Now, with this idea of a tangent segment, oops, all those, it says perpendicular, it allows us to do stuff like this, where you'll have instructions on problems where it'll say, you may assume anything that appears to be tangent is tangent. So every once in a while, they will allow you to assume something if it says so. So if this is a problem that says you may assume that you have something tangent, where does the right angle happen? At D, exactly. So how many degrees are in a triangle? 180. So what do you do then to figure out what x is? Yep. It's that quick. All right. So when you do that, you wind up with, I believe, 52. Sound about right? Because remember that your two angles that are not the right angle, these two guys will always be complementary. You've got a right triangle. Remember that? You just subtract it out. Super, super easy. Okay? With the tangent stuff, you get the tangent that touches at one spot. We're also going to start to see some right triangles where you're going to have to solve for side lengths. For example, you'll get something like this. Well, they'll draw out a right triangle, and then they'll ask you to figure out a value of x. Now, when you look at that 96 is the segment that's tangent, because it gave you that right angle. How do you solve for x? Which one of those has to be playing the role of the hypotenuse? The 100. Why is that one the hypotenuse? It's across from the 90. Okay. So you just use some Pythagorean theorem. X squared plus 96 squared is 100 squared. Looks, yeah, 100 squared. I thought I was ahead of myself. From there, remember, it's a bunch of quick buttons. 100 squared, subtract 96 squared. And whatever the square root of 784 is, remember, second square root of your answer. And lo and behold, it's 8. Okay. We're going to see a lot of stuff like that. Also, the next one that I have on here is a reminder of things of where you have been. What course comes prior to geometry? Algebra. And if you remember in algebra, one of the things that you spent the bulk of your time on was factoring and foiling. Well, guess what happens? It comes back. Same idea here. In this case, I'm trying to figure out what the radius is. Blows up over here. What of those segments is the hypotenuse? For which one of those? 8 plus x, good. That would be the hypotenuse would be x plus 8 because it's the whole thing together. So this much plus this much is x plus 8, all right? So when you start putting it together, you probably get away without it, you know, because I mean your phone does a square root. Most of these numbers are clean anyway. So when you put these things through, you're writing it out. X squared plus 12 squared equals the quantity x plus 8 squared. Now this is where most of you guys will screw up. When you have what's called junk squared, that means junk times junk. One of the things that most students will mess up, junk squared is junk times junk. And when you have that, you have to FOIL. Okay? If you forgot that, you have to FOIL out. What does FOIL stand for again? First, outer, inner, last. Last. You have to actually distribute out. Basically, FOILing is distributing twice. So for something like this, this becomes, when you FOIL it out, you get x squared plus 8x. Oops. Drew it badly. You FOIL it out first, outside, inside, last. Right. One of those things that you guys will screw up. Guarantee most of you guys will just write x squared plus 64 because you'll go too fast. Because you forget what that means. What's 12 squared? So you wind up with a problem that looks like that. You have x squared plus the 144 is x squared plus, for lack of better terms, 16x when you combine them. That is 64. What happens to the x squares on both sides? Yeah, they drop each other out. Because if you subtract going one way or you subtract going the other way, they just cancel each other out. So you don't have to worry about factoring this problem. You just wind up with a two-step equation. 144 equals 16x plus 64. What do you do first? Okay. Subtract 64. Remember, guys, this is not going to be a real difficult setup, but it's a lot of steps that you have learned in the past that you just probably have forgotten. Okay. You divide that out, and I believe you get 5. Again, it's not a real difficult thing, but a lot of times you're going to forget. Okay. Just got to be careful. Okay. You guys do that one. Shh. Take a second to give that one a shot. Nice. Remember, it's pretty quick when you write it out. X squared plus the 63 squared. Oops, can't be right. And you're just going to wind up with big numbers. Got a calculator? It should not be a big deal. Let's see, x squared. What was 63 squared? Anybody? Something ends in a 9, right? 3969, thank you. And then when you FOIL that out, you should get x squared plus 98x plus 2701. Is that right? 2401? That was close. All right. Thank you, ma'am. What drops again? X squared. X squared's dropped. And now you just subtract over the 2401. And divide that out, and I believe you get 16. Does that sound right? Bless you. Notice, it's not difficult at all. It's just a matter of remembering how to FOIL something out. Bless you. That's the biggest thing that'll happen, is that you'll forget. You'll forget that there's a middle term there. You'll just square both ends. And then you'll wind up with no values of x, and you'll be like, oh, it's 6. The other thing that we'll do with the tangents is that sometimes you might have, yes, ma'am? What numbers? This one here? Here? From here? Legs and hypotenuse? What do you mean 263? 63 squared. It's Pythagorean theorem. We got our A, B, and C, so I had A squared, B squared, equals C squared. That was just using Pythagorean theorem. That's where those came from. Same thing then goes for, there's this other one that we'll do. There's this thing called a common external tangent. Now, you have segments that start from the same spot outside a circle. If they're both tangent to the circle, their lengths are the same. Here's what I mean. We know that if these guys are going to be common tangents, they both originate from point A. When you are a tangent to a circle, you are perpendicular to a radius. What's that? What does it look like? You're right. It's exactly where it comes from. Okay. Because now, inside of a circle, what do you know about all the radii? All the radii are always the same. So these guys are congruent here. We know we've got right angles there. Well, he was alluding to, if I draw this in, isn't that a reflexive part between two triangles? Which allows you then to get, this is reflexive here, isn't this hypotenuse leg? Which then means that you've got your external tangents would be congruent because of CP/CTC. So this is why all of this stuff comes around, is because of all the stuff that we've learned before. Okay. Which also creates a what? What shape is that? It's a kite. Good. It creates a kite. The kite, if you recall, was two sets of non-opposite sides that were congruent. So two sets of consecutive sides being congruent. One set of opposite angles congruent. Your two right angles. How many degrees are inside of a polygon? Or a four-sided polygon? 360. If I take out the two 90 degrees, that means that the two angles out here, angle A and angle E, have to both add up to equal, nope, the two of them, 180. So that means that A and E would be supplementary. Okay? For example, if angle A happened to be 70 degrees, that makes E how much? 110. Now, then, you can even get further into it. If the angle here is 110, what does this arc measure? 110. It'd just be 110. You get all this correspondence of all the different rules and things that we've looked at, how everything is going to come come into play here. Excuse me. So there's a lot going on with circles because you have to kind of remember a little bit of everything that you've seen throughout the year here. Okay? It's not that they'll be terribly difficult to work with, but since there's so much material that's inside, that's why we tend to go a little bit slower with it. Okay? Which also means you can use external tangents to figure out perimeters. So if I'm going to use that one to find perimeters, if I'm tangent at D, F, and E, how much is AF? 10. How much is VE? And how much is EC? Yeah, it's really that fast. Because if these are all common, if these guys are all tangent, well, from here and here is 20. The other two are 30. Those two are 16. Add them up, what's the perimeter of the triangle? It's that quick to be able to do stuff like this. Yeah. It is that quick to figure this stuff out. Okay. At some point, we'll probably, depending upon what we learn, what we figure out, we could be able to figure out radii if we knew an angle measure. And we'll be able to figure out the radius of that circle if we know an angle measure because we can do trig. We can work backwards to figure all this stuff out. Okay. There are, oh man, what is it? Probably not this weekend, but next weekend. I've got a couple of extra problems that I usually give students that are one giant diagram that has, I don't know, 15, 16 questions in one part because there's so much info you can get out of these things. Not tough, it just takes time to get through them. Be honest. Yeah, you mind? I don't know, where do you think would fit? All right. So, try this one then. What do you do now? What's your algebra going to look like now? Exactly. Let's set them equal to each other. It's not that you have to overly math or make any extra math stuff here. It's just a matter of knowing that you get that external tangent, that spot that's going to be the same. It's shared. That means these two have to be the same. So. This now becomes just a multi-step algebra problem. Again, it's super easy to work with. Remember, you're working backwards from the order of operations. What do you have to do first? Yeah, add the 10. Good. So you add the 10 to both sides. Then what? And then lastly, good. So you take a square root over an equal sign. What do you have to do to your answer? Remember that? What's that? Well, yeah, with square root, but what do you have to put in front of it? Remember, when you take a square root over an equal sign, it's always plus minus. Reason being is square root means what are two numbers that are exactly the same? that you multiply together to get 9. Yes, ma'am? I divided both sides by 3. Because remember, when you have square roots, it's what are the two numbers that are the same, you multiply together to get what you're taking square root of. 3 times 3, 9. Negative 3 is also 9. So you can get negative answers for your value of x, because if you substitute in, if I square a negative, what does it become? Positive. It's okay. It's perfectly fine. You're going to see that a lot with circles. You saw that earlier, I think, sir. You saw that earlier when we did our first circle stuff, when we had segments. You guys remember when we did those adding to the segments? Some of those, some of the values of x that we're getting on that, remember the worksheet that I made? It was giving us negative values of x. It was like a was -1 or something. I vaguely remember it. Where you guys are like, wait, you can't have negative, but when you add it together, it worked. So same thing goes for here. Sometimes you will get a plus minus. So you got to make sure that you write plus minus and then just think, will that negative actually work? In this case, yes. All right. It's one of those things you got to double check. Let's see. Oops, sorry. Sorry, I thought I had this embedded. I did not. Go. Come on. There we go. What do you do now? Do you remember this? Yeah, this is what we had put. Thank you, ma'am. Now, this is the one where most of you guys are going to have trouble. And what I wanted to do is make sure we walk through one like this, because this was always the weirdest one when you're in algebra classes and all that as well. It's still the more, I wouldn't say difficult, but it's the one that takes a little bit longer. Even in Algebra 2, when you see these, most people go, they forget. You guys agree that they have to be equal? So what we have to be able to do, we have 2x squared plus 3x minus 2 is 3. Okay? Now, what do you do to get a side equal to 0? Remember, when you're going to factor something, you have to hit one side equal to 0. So you guys are pointing going this way. So I'm assuming that means move the 3. How do you move a positive? Subtract it. So you get 2x squared plus 3x minus 5 is 0. Now, when your leading term coefficient, remember what that means? Leading term coefficient, number in front of the highest degree. In this case, that would be a 2. It's in front of the x squared. When your leading term coefficient is not equal to 1, you have to do the long form of factoring. The way that I always did it was this. What times what is negative 10 that you add together to get 3? What are your factors of 10 that add to 3? Well, what are your factors of 10? 1 and 10, and 2 and 5. One of those has to be positive, and one of those has to be negative for them to add to 3. Which one is positive, which one is negative? 5 is positive, and 2 is negative. So what we do is that this is what we call factor via grouping, or split middle term, one of those lines. You would rewrite it as 2x squared minus 2x plus 5x minus 5 is 0. You're basically taking a trinomial, 3 terms, and turning it into a 4-term problem. By doing that, you can then get what are called GCFs. What do those guys have in common? 2x. Good. So you factor out a 2x. You're left with x minus 1. What do the 5x and the 5 have in common? 5. So you factor out a 5. Oh, just 5, because one has an x and the other one doesn't. And you're left with x minus 1. Are the 2 things that are in parentheses the same? Yep, that's a good sign. That means you're doing it right. You write that down. And what's left? 2x plus 5. Finding zeros and factoring and stuff like that is one of those things that you learn that never goes away. It's kind of like adding, subtracting, multiplying, dividing. Factoring does not go away. You will see it in this chapter a lot, and you will see it pretty much in every chapter in Algebra 2, most chapters in pre-calc, and so on and so on. It's one of the most common things that you'll see. When you get to this part here, remember when you have 2 terms that are set equal to 0, you set both terms equal to 0 to solve for x. Again, this is nothing new. You guys have all done this many times. Solve for x, you get 1. Subtract 5 divided by 2, you get negative 5x. You then have 2 answers to choose from. You got to figure out which one works. Do they both work, or do neither of them work? Which means you got to go back to the original problem. The original problem was it 2x? If I substitute in for x, which one of those works? Well, what's 1 squared? 1. What's 2 times 1? 2. Okay. What's 3 times 1? 3. Very good. What's 2 plus 3 minus 2? 3. So 1 works. Okay. That one works. Negative 5 halves. If I square negative 5 halves, well, basically you can do this. 5 halves is the same thing as what? 2.5? Negative 2.5. You okay with that? So if I type it in my calculator, I can do 2 parentheses, negative 2.5 squared. Oops, sorry, I got to put that. Put parentheses in the wrong spot. Less than I hate this calculator. 2 parentheses, 2. I have to put parentheses around it because it's negative before I square it. Plus 3 times negative 2.5. And then I subtract 2. I got 3, didn't I? That means both of those values of x work. With these factoring ones, you will see sometimes only one of them works, sometimes both of them work. You always have to check it. So they both work. So in this case, this problem has 2 answers. 1 or negative 5 halves. I just want to make sure you guys saw that as well. I don't know if we have too many of the larger factoring style today. I do know for certain we will see a bunch of them tomorrow. I want to make sure it's a little crash course of remembering how that works. Okay? Homework-wise tonight isn't too terrible. It's pretty quick stuff. Got a sequence here. This is on page 767. I want to say it was 6 through 19. I want you to do all those tonight. We'll add more for this stuff tomorrow with a lot more of the factoring. Basically, our day tomorrow is going to be factoring, so good times. Okay? What's that? Yeah, right? It wouldn't be bad to just review it. I mean, we'll do more of it tomorrow to remind you of how to do the higher degree stuff, but